Hey folks, okay, I just wanted to go through the rundown for lab exercise 4. So this one's going to be due in, I guess, 3 weeks, so November 17th. So you've got sort of the usual 2 weeks of class plus the 1 week of study break this time around. I do recommend starting this one early because it is bigger than the labs that you've dealt with so far. I'm leaving most of the design up to you, and you're probably going to have 6 or 7 functions to create, and it's going to be working with arrays. So this is one that I recommend you get going with fairly early. As usual, there is a link for syntax examples. So this one focuses on the array side of things. So if you want to go through and get a recap on the various bits and pieces of syntax for creating and using arrays, they are in there. And as usual, same standards as we've been applying so far. What I might do here is show you an example of the kind of intended program in action, and then we'll take a look at discussing how to go through and create it a little bit. So the idea is, again, assuming you've gone through and you've grabbed your LabX4, I'm just going to show you a kind of a sample run of what I want this thing to do. So this is, I've gone through and written my own version of the program here, and I'm just trying to run the beast. So the idea is you're going to be letting the user supply a whole bunch of just numbers to store, and giving them the ability to print out what they've stored so far, to search what they've stored so far for a given number and count how often it's there, to print out a list of the commands that they're allowed to enter. So this thing's going to go through and repeatedly give the user a prompt saying, please enter a command. They can choose to either print the help menu so they get a list of the commands that you see in front of you here, or they can print the values that they've stored so far. Now, obviously, at the beginning, they haven't stored anything yet. They can add a new number to storage. They can count how often a given number appears, or they can quit. And of course, this is going to have all the usual error checking of if it asks them for a command and they enter an invalid command, it'll give them an error and try again. If they wind up needing to enter a number and they enter something that isn't a number, it'll give them an error message and prompt them to try again. So we'll have all our slew of error checking. But this is the basic set of functionality we want to provide for the user. So a little blurb at the beginning telling them about the program, a list of the commands that they're allowed to enter, and then a prompt to go through and say, okay, please enter one of the following commands, an H, a P, an A, a C, or a Q. And so the idea is the user should actually be able to enter either upper or lowercase. So if they enter an H, for instance, it should go through and print that menu, print that help menu. Same thing if they enter a lowercase h, it should, lowercase h, it should, oh, yeah, wondering why this isn't working. And of course it is working, it just appears the same on the screen. So they can go through and enter a command, prints the menu again. We can go through and print the values that are currently stored. And of course, there's nothing stored yet. They can go through and, again, if they wanted to print the menu again, print what's currently stored. We can go through and add a new number to store. And it prompts them to enter the value that they want. And of course, this can be any value, so any numeric value. So floats are okay. I could enter 1.5. And it'll say, okay, I've added 1.5 to the data store. So if I print it now, I should see the 1.5 in there. Maybe I add another one. Let's add 10. I add another one, and -3, and print it out. And so I'm getting the values that I've entered and in the order that I'm entering them. So I'm presuming that in the background, this thing's got an array, and every time you add a new value, it just adds it in the next free spot in the array. So we're going through, we can add values anytime we like. We can add duplicate values, right? I can add a couple more, oops. Yeah, if I enter something that's not a valid command, it tells me that's not a valid command. Let's see. Let's say we enter A again to enter another number. So let's throw a couple more 10s in here. So if I print it now, right, duplicates are okay. We've now got the 5 values that I've entered. And maybe I do something like a count. So how often does 10 show up in there? And it goes through and figures that out. And of course I could do a count for, something that isn't in there. And it tells me it appears 0 times. So we've got our usual collection of ideas. I can throw in an invalid command and it should tell me that's not a valid command and give me a chance to try again. So this is what we're trying to give the user as functionality. And if I go through and, again, try and search for a value and I specify something that isn't a number, it tells me that's not a number and gives me a chance to try again. Right? And eventually the user's going to decide that they want to quit. And it shuts down at that point. So that's the kind of functionality that we want to go through and provide. So in terms of the lab objectives, this pretty much goes through and spells out exactly that. It's a program that allows the user to store and search this set of numbers. We're going to have a maximum of 20. Use 20 as your max because I'm going to be testing to see if it correctly stops when it gets full. So adding new numbers over time. And again, pretty much a description of what we expect the program to be doing. Right? It starts off with that little description of how to use the program, right? A brief command summary, a brief welcome. And then it goes through displaying this help menu and waiting for the user to enter a command, right? So it just repeatedly prompts the user, gets them to enter one of those letters as a command, an H, a Q, a P, a C, or an A. And again, should be letting them enter upper or lowercase. Gives them an error message if they pick an invalid command. And it goes through and takes the appropriate actions when they choose to print or to get a count or to add a new value. And again, there should be reasonable error checking in there. If the user decides to add a value when the array is already full, then it should give them a message saying, nope, sorry, it's already full, can't add another value. If they choose to print and it's empty so far, then maybe actually have it print out on a data store is empty so far. Otherwise, go through and print what's in there. So again, I want you to have suitable error checking, and I'm going to, for the most part, leave the design of this up to you. Now, I did include a sample run in the description there, but that's pretty much the idea that we just ran through, running that sample version of the program. Right? It's just going through, giving a little blurb at the start to get the ball rolling, and then just waits, prompts them, please enter a command, gets the command, and does whatever it says. Right? So this is pretty much just a recap of the kind of thing we just ran through, and eventually shutting down when they quit. Now, you do have to use arrays as your data storage for this, right? This lab is about practicing with arrays, so you've got to use an array to store the set of up to 20 potential values. They should be either floats or doubles, right? They've got to be able to enter real numbers. So I don't mind whether you use an array of floats or an array of doubles, but it does have to be one of those two. You do need, whatever design you come up with, you do need to make appropriate use of functions and parameters. So it's pretty likely that what you'll wind up doing is having your main routine declare an array of size 20, right, your maximum size, using appropriate constants, to create your array of size 20 and have an integer variable or a long variable that goes through and counts, that keeps a count of how many values are in the array right now. So every time they add one, that bumps up by one, right, so that you can check when the array is full and you know how many values you currently have stored. Now this means that the main routine is going to be calling a variety of other functions to actually do the work, and it's going to be passing it the array and the current size where necessary. So I am leaving it up to you to design these functions yourself, but if you're having trouble getting started, then kind of where I would see things going is you've got that pretty distinct set of actions, right? You need to be able to get a command from the user. So I would recommend having a function that does that, right? Prompts the user, gets them to enter a command, checks that it's actually a valid command, and either repeats or returns it. So you've got this like get command function. maybe one function to go through and display that help menu so that if they pick H, you can just say, okay, well, call, print help or something like that. Maybe the same thing for that little welcome blurb at the beginning. Have a welcome function that just runs that little descriptive part at the start. You're going to need to be able to get numbers from the user, either when they want to add a new value or when they want to search for a value. So have a function to get a number, and that should, again, prompt the user, enter a number, read it in. If they enter something that isn't a number, right, if cin fails, clear the buffer and try again, and eventually returning the value that they provide. Right, probably a function to go through and print the current contents of the array. So if they picked P, then the main routine could call print array or something like that, and it goes through and prints the current set of values. So main would probably need to pass the array as a parameter and the current size as another one. Right, a function to get a new value to add to a function to add a value to the array. So this would obviously have to go through and say, well, if the array is already full, I can't do this, and just tell the user, sorry, you can't add anymore. But if the array is not full, then we want to call our getterNumber function, go off, get the new value, and store it in the next position of the array. But that means that we are actually increasing the current size of the array. So either maybe your function returns the new size, or maybe you pass the current size of the array by reference so that this can increment it by 1, something along those lines. But you've got a function to go through and add a new value to the array. And similarly, a function to go through and count how often some value appears in the array. So maybe the main routine calls, count values, and in that function you use getANumber to get the value to search for, and you have a loop that goes through the array and says, okay, well, let's count how many times this value appears in the array. So again, the main routine is going to have to pass the array and its current size so that count can go through the current contents. So your main routine is going to be calling these functions, quite often passing the array and its size as parameters. That would be kind of my initial thought on what a good breakdown would be. Usual ideas for deadlines and late penalties. Again, this one's due, I think, on the 17th, if I recall correctly. Yes, Wednesday the 17th. So got a little bit of time to work on this one. But again, obviously, there's more moving pieces in this. So I do recommend starting early. And again, I would very much take an iterative process for this. Right, at first, write out your functions and just get your function definitions more or less right. And you might need to tweak those later, but get an initial version of them, get it to compile. And then go through and get them working for just correct input. Don't worry about any of the error checking. Don't worry about any of the trying again kind of idea. Just get it to work on the basics if the user enters things perfectly. Once that's running, right, then you've got the core structure of your program. Then piece by piece, you can go through and say, okay, let's add the error checking to get a number. Let's add the error checking to get a command. Let's add the error checking in add a value just to double check that the array is not full before we try and add it. Right, so just add the error checks one at a time, but still not worrying about getting it to try again at this point. I mean, obviously the try again doesn't apply to the array is full. If the array is full, then trying again isn't going to help you to try and add another value. But forget a number and forget a command. Get the error checking working without worrying about trying again. And once all of that works and it gives you your error messages when you do something wrong, then go in and start getting it to repeat. So this would be my approach. Again, start early. I'd try and recommend that you get the basic, no error checking version working before the break, and that way, kind of over the break, you can, and in the couple of weeks after or the week after, you can go through and start getting or the few days after, you can start getting the error checking and repetition working. But again, start early, and you'll have a chance to recognize where you're running into problems, and I'll have a chance to be able to help you. All right, I think that was what I wanted to go through.